So our shortcut is going to use these characteristics and these patterns that we've noticed when we looked at the A, the B, the C, and the D values separately. Now we're going to combine them all together and put together a graphing strategy for graphing sine graphs and cos graphs. And this graphing strategy I call DAB-C because that's the order that we're going to do things in. It's a little bit different than transformations because transformations, we always did all of our stretches and compressions first and translations last. But because of patterns that happen within this, we can use the following strategy. We can start with our D value. Our D value changes your center line. So the first thing you can do is draw your center line or sinusoidal axis. So we use a dotted line like an asymptote and draw our center. Next, use your A value. Remember, your A value tells you your amplitude. So we can use our amplitude and go from our center line to go up to the maximum and down to the minimum. And we can label our maximum and minimum on our y-axis. So we'll write all this information down, and then you're going to see with a couple of examples how this strategy works to let us graph things quickly, easily, and actually a lot less work than it would be if we used transformation. So at this point, you will have labeled your center line and labeled a max and min. You will be done labeling things on your y-axis. Next, your B value is going to figure out your period. So remember, we have a formula that your period is 2 pi over your B value. And then we can use that B value to calculate our period. Whatever our period is, we label it on our x-axis and divide that into 4 equal sections. Because on our regular sine graph, we had one period and our axis family nicely into 4 equal sections. So now we write our new period and cut that into 4 equal sections. Next, in DAB-C, I have a dash between the DAB and the C. That's not just so that it reads easier. We actually do something with the dash. The dash means that we graph our sine or cosine graph without the phase shift with a dotted line. So the dash represents a dotted line. In DAB-C, we're going to temporarily draw the graph without a phase shift, and that will make drawing the graph with a phase shift easier, which is the last letter. The C value is your phase shift. The last thing you're going to do is translate your graph either left or right. So let's do a couple of examples to see what this looks like and how to use DAB-C. Was everybody almost done writing the letters down? Do I need to go up a little bit? Okay. Is that enough? So what we're going to do is off to the side here, I'm going to write dab C with the dash. And we are going to go through the process of what it looks like to graph. First of all is the D value. Our D value is 1. So the very first thing that we're going to do is at 1, take out a red pen, draw a dotted line, y equals 1 for our center line. And I'm going to put a check mark above the D, because that's all you have to do for your D value, is find out what your center line is and label it. Next is our A value. Our A value tells us our amplitude. In this question, our amplitude is 3. And one of the things that I do, I sort of look at the D and the A value together, because I need to figure out my scale here, where I'm going to draw my graph. I know that D is going to be my center line, and A is going to be my amplitude, which is the distance from my center line to a maximum and center line to a minimum. So the fact that my A value is 3, I know that I'm going to have to go up 3 units to 4, and down 3 units to -2. So we use our A value to label our maximum and our minimum. I can now go to my A value and add a check mark. That's all we have to do for our A value. Next, our B value. Our B value in this case is 2. Our B value figures out our period. And I've got it in green up at the top there. 2 pi divided by B, in other words, 2 pi divided by 2, our period is going to be pi. So the next thing is along your x-axis, choose a spot, doesn't really matter where, mark that as pi and divide it into 4 equal sections. Label those 4 sections. When labeling those 4 sections, usually the middle one is the easiest one to do next, because that will be half of pi. And then the first one is going to be half of pi over 2. That'll be pi over 4. And then the third one, if one of them is pi over 4, 1, 2, 3 pi over 4 will be the third one. So your B value is probably has the most calculations to do in your graph. You have to figure out what the period is, make a mark on your x-axis for one period, divide it into 4 equal sections. Next is the dash. For the dash, we take our graph. This is a cos graph. And again, you're going to hear me say for cos graphs start at a maximum. For sine graphs, you're going to hear me say sine graphs start in the middle going up. Again, you think of your regular sine graph, your regular cos graph starts at the maximum. So now, when I go on to my graph here, when I'm doing the dash part, that means draw your graph without the shift. A cos graph starts at the maximum, so I label a point at my maximum. Then I go to my center line and label a point. My minimum, label a point, back to center line, and then back to maximum. I'm just going to do this with a dotted line. Because this is what our graph would look like without a shift. It's not the actual graph. It's just to give us a visual before we do the shift. That's what the dash means. Finally, we get to our C value. Our C value says we need to shift everything pi over 4 to the right. So we look at our scale. Pi over 4, luckily for us, is already labeled on the scale. So we know that pi over 4 to the right would be moving everything 1 ticky mark to the right. So I take this top point and I move it over. I take this point and move it over. This one, move it over 1. This one, I move it over 1. And this one, I move it over 1. is the C value. In transformations, you would have had to take all 5 points from your regular graph and do a bunch of mental math transformations to all 5 of those points to find these 1, 2, 3, 4, 5 blue points. This method of DAVC makes it a lot faster and easier for us because we've noticed some patterns. We noticed that your D value always changes your center line, your sinusoidal axis. Your A value is always equal to your amplitude. And so if we have our center line, our amplitude can find our max and our min easily. The B value affects your period. We have a formula that your period is 2 pi divided by your B value. So that lets us figure out that the period was pi divided into 4 equal sections. Once you have that, you can draw the graph without a phase shift. That green dotted line was drawing the graph with the right center line, the right period, the right max, the right min, but without the phase shift. And if you draw that green line, then when you go to shift things over, it becomes really obvious and easy to do. So we're going to do another one just to make sure that we're ready. Okay? Again, off to the side here, just so we can follow along with the techniques, I'm going to write DAVC. I'm going to draw my axes. And for this one, I already am thinking about my center line and my max and min when I draw my axes so that I have it nicely spaced. So I knew my center line was going to be at y equals -2. That's my D value. I can check that off. Next, I know that my amplitude is 4, so I can go up 4. My maximum is going to be a +2. Down 4, I know that my minimum is going to be at -6. That's all we need to do for our amplitude, so I'll check that off. Next, our period is 2 pi divided by our B value. So I take 2 pi, our B value is 3. So we know that our period is 2 pi over 3. We can use this, pick a spot somewhere on our x-axis, label 2 pi over 3, divide this into 4 equal sections. Label those 4 sections. So half of 2 pi over 3 would be pi over 3. Half of pi over 3 would be pi over 6. The third one, 1 pi over 6, 2 pi over 6, 3 pi over 6 would be the third one. And we have now successfully done the B value. Next, okay, a little note. We are going to draw it with a dotted line without a phase shift. But a little bit of a note here is I want you to notice that there is, sorry, not a horizontal reflection, a vertical reflection here. What would that do to a sine graph? If you have a vertical reflection for a sine graph normally starts in the middle going up. A vertical reflection will tell us that it starts in the middle going down. If you had a vertical reflection for a cos graph normally starts at a maximum, but a negative cos graph would have that vertical reflection and start at a minimum. So for our dash, we need to start in the middle. There we go. Going down because of the vertical reflection. So we'll go down, next taking mark to our minimum, then back to the middle, then to our maximum, then back to our middle. And here is our graph without the phase shift. So that is the dash. The dash is a little bit more complicated this time because of that negative. And finally, our C value, we are going pi over 6 to the right. No, pi over 6 to the left, because it's plus pi over 6. Pi over 6 is labeled here on our graph, but pi over 6 to the left, we would have to add a mark and label negative pi over 6 to go to the left. We are now going to take each of the 5 points that we have and shift them, in this case, 1 mark to the left. This one will shift here, 1 mark to the left, 1 mark to the left, 1 mark to the left, 1 mark to the left. And your final graph is a nice round curve through the points, no sharp straight lines. You'll lose a half a mark for the shape of your graph if it's not a nice curve through all of those points. And we have now had our phase shift. So we have graphed everything completely. This is the technique that we're going to use for graphing all of our sine and cosine graphs.